Hello everyone, my name is Gina Chapman and this is my final submission for the class CPSC 2100. So I'm just going to get right into it. So I'm going to show the first problem right here on screen. It says, suppose you're given two strings as one and as two. You would like to lace these strings together by successfully alternating elements of each string. If one string is longer than the other, then the remaining elements of the longer string should simply be added at the end of the new string. So yeah, let's get started with this. So we're going to start by defining a function which is going to be called lace strings. And it's going to take string 1 and string 2. So we're going to create an empty list to hold the result. So we're going to name that result and make it empty. And then we're going to, so first we're going to get the length of the shorter string. So we're going to go minimum length, which is min. So basically this is just checking which one is shorter. Now we're going to create a for loop, and it's going to go through each of the characters and alternate characters, just like how the prompt says. So we're going to go for I in range. So we're just going to add, we're just adding the first character, and then we're going to add the second character from the second string, and it'll just go back and forth between those two. Okay, that's not what I want to do. Okay, so after the loop, there may be some remaining characters. So for this, we're going to add, depending on which, we're going to add two commands, and depending on which string is longer, it's just going to add the extra characters from the end of that longer string. So if the first string is longer, and then we're gonna add the rest of the characters from that, and if the second string is longer, we're gonna add all the characters from that. So that'll cover all the extra characters that don't fall into this for loop right here. So now we're going to join all the characters into a single list and then return it. So we're going to do return dot join, so turning the list into a string. So that's it for the function. Now I'm going to grab these two test cases, and so these are the expected outputs with these strings. So let's run this and see if I actually did it right. Okay, so it looks like I did everything right. I got the expected output. So I guess this first problem is done. So we can save this. And now we move on to problem 2. So again, I'm going to put problem 2 up here on the screen, and it says write a Python function that creates and returns a list of prime numbers between 2 and n inclusive, sorted in increasing order. A prime number is a number that is divisible only by 1 in itself. This function takes in an integer and returns a list of integers, and then it gives me a bit of code to start with. We're going to start with the function. Find a function primes list, and then n. So we're going to again create an empty list to store all the prime numbers. So that's that. And then we're going to loop through each number from 2 to n to check to see if it is prime with a for loop. So now for number in range 2 in, I'm going to do +1 so that n is inclusive. So we're going to assume the number is prime initially. So this is just a base assumption. And then so we're going to check, next we're going to check divisibility by all numbers from 2 to the square root of the number. Yeah, here's another for loop inside this for loop. So for I in range, so 2, the integer 5 plus 1, if the number mod I is equal to 0, so if the number is divisible by I, basically saying, basically this little part here is that if the number is divisible by I, then it is not going to be prime. So we are going to set is prime to false, and then we're going to break the loop, and then we'd be done. So this is basically going to go through everything, and then we're going to do if is prime. We're just going, so if we run this little code and it goes through all of the numbers and none of them are prime, then it's just going to continue. And then if it is prime, we're going to add that number to the empty list up here. And then at the end, I'm going to return primes. Okay. That should be it as for the code. Let me put in a little example here. So if we were to put in 20, here is what should come out as the primes of that. So let's see. That is it. So that's it for this problem. Let me save this really quick. And yeah, on to problem 3. So again, problem 3. Here's the problem up here on the board. Here's the problem on the screen. It says you are given a dictionary that maps integer keys to integer values. Write a function that returns a list of keys that map to dictionary values that appear exactly once. So this function takes in a dictionary and returns a list and returns the list of keys in increasing order. So we're going to first create a define a function. This is part of what I was given on the problem. So then we're going to create an empty dictionary to count how many times each value appears in the dictionary I'm given. So we're going to do value count, and for now we're just going to make it empty. Next we're going to go through each value in the dictionary to count the occurrences. So we're going to do for loop for value in values. So for each value in the dictionary. So if the value in value count. So for values and value count. So if the value is already in the count, it's going to increase the count. So in the value count. So it's basically just holding the number of values. Oh. So it's just holding the number of values in each number it goes through. If that makes sense. So this thing, so if the number is already in this dictionary up here, it's going to add, this is a key. We're going to add a, just add the count. That makes sense. I'll explain it at the end. So if it's not yet in the value count, we're going to initialize the count. So value count, a value that it's on equals 1. So just basically creating this dictionary up here. And now we're going to create a list of keys where the corresponding value appears exactly once in the dictionary. Basically what it's just going through and counting how many of each number is in a dictionary, and we're going to create some keys, basically excluding all of the numbers that appear more than once. So we're going to create, what do I do? Create results. So key for key. Value in value. So like I said, this is going to basically go through the keys, and if the value count is going to create a key if the count is equal to 1. And now we're going to return the sorted result. So it should put it in numerical order from least to greatest. So basically it's just taking, if we're starting here, it's counting up all of the numbers in the dictionary that I input. And if it's more than 1, then it does not get a key. But the ones that do get a key are returned, and which would be the unique value. So this, the whole point is to find the ones that are only in there once. So that's the end of the code. So now I'm going to put in some test cases here with their expected outputs. Now I can just run this. So if we go through this, let me just explain this and go through this. 1 is only once. So 1 is in there 1 time, 3 is in there 2. So yeah, this is what I was expected, and that is what I got. So that is it for this problem. We save, and then it's on to problem 4. So once again, we're going to put problem 4 on screen. So in this problem, you implement a class according to the specifications in the template file that I was given. The file contains a person class, similar to what I've seen before. and a US resident class, which is a subclass of person. Person is already implemented, so I won't be messing with that. They'll have to implement 2 methods of US resident. So just so that's in there. And now we're going to another class, which is the US resident class, which is a subclass of person. So we're going to define the function initialize self name status. So it's taking these 2 from person, but we're doing this right here. So self name status. So this just creates a new object. So it inherits these 2 from person and adds status, which can be citizen, legal resident, or legal resident. It raises a value error if it is not one of these 3 strings. So we're going to call the constructor of the person class. So super to grab the name. So this is grabbing the name from the person class. Should just space this out a little bit. Okay, so this grabs the name from the superclass, which is person, and then we're going to validate the status to make sure it's one of the acceptable values. So valid status statuses, which are citizen, resident, and illegal resident. So those are 3 statuses it can be. So if the status not in valid, the status isn't in there. If the status isn't in one of these 3, then we're gonna raise a value error, and it's going to say valid status must be one of citizen. Oh my goodness, can I type citizen? So it's going to raise a value error. It's going to say this, and then we're going to set the status. So we're going to set the status for the object, and then we're going to define a second function. This is going to define, this is just going to grab the status. From self. So it should just grab it from here. And then we're just going to return self.status. So it's just grabbing this. So I'm going to save that, and now I should be able to put some test cases. First and last name and citizen. So if I go and print this, should get, yep, okay, so that's the status. And then if I go, so if I put in something that is not a valid status, I should get an error. Yep. So it raises a value error, and that is exactly what it's supposed to do. So, yay, that's it for that problem. Now on to the last problem. Problem 5, which is a container problem. Oh, something's in my eyelash. Okay. So here's the big code block I'm given. So I'm giving the superclass, and then I'm asked to write a class that implements the specifications below. Do not override any methods of container. So now we're going to create a class called a set. And it's going to take it from container. So it's a subclass of container, and it simulates a set. It allows for the removal of objects and checks if an object is in the set. So we're going to make a function called remove. I'm just going to take self and e. So this assumes, like I said, that e is hashable and removes e from the container if it exists. So if e in self So basically, if e exists in the container, we're going to delete it. And that is that. Oh, we need to add this. Okay. So that's that little function right there. So now we're going to create another function that is called is, and we're just going to check to see if e is in it. If e has been inserted into the container. So this returns true if e has been inserted into the container and not removed, and then false otherwise. So basically, if e is in there, it's true. If it's not, then it's false. So return e in self. So basically, just saying if it's in there. If you're going to return it, then it's true. If it can't, then it's false. So that's that 10-line code that I had to do. So I'm gonna put these examples in here to see if this code actually works. So here's all the examples. So basically just saying what it does, and we're gonna So just create a new set, and then we're going to insert 4 again, try to remove number 2, which is not in the set, and then print D1. So the expected output is 4 colon 2, since 4 appears twice. And then D1 remove 4. Its output is empty since 4 was the only number. Even if it was twice, it removes all counts of that number. And now for example 2, create another set, put 4 in the set. If 4 is in there, it's true. Insert number 5 into the set. checks it again, and it's true since it's in there, and then removes number 5, and then false since it's been removed. So let's run this for 2, true, true, false. So that's exactly what it should be. So yeah, that's it for this code. If you have any questions or concerns or tips, just let me know. And I guess this is my last video for this class. A very exciting time. This class learned a lot of things. So thanks for watching, and I'll see you in the next video. Bye!